In today's video, we will learn about motion in one dimension. There are three important components of motion that is helpful to know, them being displacement, velocity, and acceleration. Displacement of an object is defined as its change in position and is represented by delta x. Velocity is a vector quantity having both magnitude and direction. In everyday terms, speed and velocity are used interchangeably. But in this case, speed of an object over a given time interval is the total distance traveled divided by the total time elapsed, while velocity is the total displacement over the total time elapsed. Then we have instantaneous velocity, where it's the limit of the average velocity as the time interval becomes increasingly smaller. Where velocity is the change of displacement over time, where acceleration is a change of velocity over time. We can see below that acceleration is represented as a, and acceleration can be defined as delta v over delta t. As the same as instantaneous velocity, instantaneous acceleration is the limit of the average acceleration as the time interval goes to 0. So we know that displacement is defined as the change in position of an object and is represented by delta x. If we look at the problem below, it says an object moves from point A to point C along the rectangle shown in the figure below. In part A, they want us to find the distance covered by the moving object. So our object moves from A to B, then B to C, and we're asked to find the distance covered. So we see in our key that square unit is 1 kilometer. So if we count each unit from point A to point B, we'll see that there's 1 kilometer, 2, 3, 4, 5 kilometers. So the distance from point A to point B is equal to 5 kilometers. Then if we go from B to C, we see that we have 1 kilometer, 2, 3 kilometers from point B to C. And we're asked to find the total distance. So in order to find the total distance, we can add our lengths AB plus our length of BC to find our total distance, which in this case, AB was 5 kilometers and BC was 3 kilometers, which will give us a total distance covered of 8 kilometers. In part B, they want us to find the magnitude of the displacement of the object. So in part B, they want us to find the displacement, so the distance covered directly from point A to point C. You should recognize that it forms a right triangle. So now that we have a right triangle and we know the length of AB and the length of BC, we can use Pythagorean's theorem to solve for the length of AC. So if we write out Pythagorean's theorem, we have AB squared plus BC squared is equal to AC squared. We put in the length of our sides. We can solve for AC. If we take the square of our known sides, if we add our sides together, see we'll get 34 is equal to AC squared. In order to get AC by itself, we can take the square root of both sides, which will cancel the square over the AC, which will leave us with AC is equal to the square root of 34, or is about 5.83 kilometers in length. Now that we know the difference between average speed and average velocity, let's look at problem 2. In problem 2, it says John drove south 120 kilometers at 60 kilometers per hour, then east 150 kilometers at 50 kilometers per hour. And in part A, they want us to determine the speed of the whole journey. So we know that the average speed is the total distance over the total time. So in A, we're trying to find the average speed. So we're going to sum up our total distance traveled. So from point A to B, it was 120 kilometers. And then from B to C, it was 150 kilometers. Divided by our total time. And it said from part A to B, he was traveling 60 kilometers an hour. So the time it took for John to drive 120 kilometers would be 2 hours. And then the time it took for John to drive from point B to point C at a speed of 50 kilometers per hour, we see that 50 goes into 150 three times. So it would take John 3 hours to travel 150 kilometers. If we were to add these values together, if we added our total distance and our total time, we'll see that we can find the average speed of the entire journey. And when we do so, we'll see that his average speed is 54 kilometers per hour. And in part B, they want us to find the magnitude of the average velocity for the whole journey. So we know the average velocity is the total displacement over time. So our total displacement is the length of AC. In order to find AC, we have the lengths of A and B and C, so we can use Pythagorean's theorem to solve for AC. So AB squared plus BC squared is equal to AC squared. So AB was 120 kilometers in length, and BC was 150 kilometers in length, which is equal to AC squared. If we square both sides, we'll get 14,400 plus 22,500 is equal to AC squared. If we add our lengths together, we'll have a distance of 36,900 kilometers is equal to AC squared. To get AC by itself, we can square both sides. So if we do so, our square and our square root will cancel on AC, which will leave us with the value of AC is equal to the square root of 36,900 or 192 kilometers. So now we know that the distance from A to C is 192 kilometers. Now we can take our total change of displacement over time. So to find our average velocity, we would need our delta x over delta t, which we have found delta x, which we know is 192 kilometers, and our total time was 5 hours. We can find that our average velocity is equal to 38.4 kilometers per hour. We have learned that velocity is the change in displacement over time. Now if we look at acceleration, we see that acceleration is the change in velocity over time. If we look at the problem below, in problem 3 it says, find the instantaneous acceleration at points A, B, and C based on the velocity as a function of time graph on the right. So if we look at point A first, we're trying to find the instantaneous acceleration. So we're going to have to find what the final velocity and initial velocity are, and our final time and initial time. If we are to look at our graph on the right, we'll see that our y-axis is our velocity, and our x-axis is our time. And if we were to find the slope, we would see that our slope is y over x, which is velocity over time, which is the same thing as instantaneous acceleration. So for each of our points, we can look at the slope of our graph to find our instantaneous acceleration. So for point A, we have to find our final velocity and our initial velocity. So after 10 seconds, we see our final velocity is 10 meters per second, and that our initial time at 0 seconds, we had an initial velocity of 0 meters per second. When we simplify this, we would get 10 meters per second over 10 seconds, or an instantaneous acceleration of 1 meter per second squared. In part B, we see that our slope is parallel with our x-axis. So for point B, if we find the slope that point B lays on, so we can see that our final velocity after 20 seconds is 10 meters per second. and that our initial velocity at 10 seconds was 10 meters per second. If we simplify this, we'll see we'll have 0 meters per second over 10 seconds, which is equivalent to having instantaneous acceleration of 0 meters per second squared. Finally, in part C, we see that we have a negative slope, so we should assume that our instantaneous acceleration will be a negative value. So if we look at our final velocity at 30 seconds is negative 10 meters per second. At 20 seconds, our initial velocity is 10 meters per second. And if we simplify our fraction, we'll have negative 20 meters per second over 10 seconds. And we can simplify this fraction to get our instantaneous acceleration as negative 2 meters per second squared.